Okay, we're going to look at some derivatives here using the product rule. So we have to start by noting that we have the product of two functions, and the derivative of a product is not product of derivatives. As you can see, or as we actually noted in class, you have two functions again. You have this first function, and you have the second function, and they're multiplied together. So we call those f and g. First function is f, second is g. And the product rule, taking a closer look, is that we think of that first function first as a product. And then for the second function, we're going to differentiate that second function. Okay, so this is the derivative of the second function. And the second function now is thought of as a product, and then we're going to differentiate now the first function here. Okay, so here's the derivative of the first function. You can remember this by maybe saying f, and we'll change this here for us, times that g prime, and then this will be plus g now times the derivative of f. So there's various ways to look at this. Sometimes I've used the triangles and the squares, meaning if I have to differentiate here, the product, and this is just like what you're seeing with the f and g, we can think of that as the first function is left alone, and the second function we differentiate, plus the second function times the derivative of the first. So however you want to remember this, pick your poison, but really know that the derivative of a product is really not product of derivatives, and this is what we mean by that. Okay? The derivative here of a product is not product of derivatives. This is not true, and we proved this in class. So nevertheless, this is where students make the biggest mistake. So make sure you don't make that mistake, and now we're going to see some examples of that product rule. So for the first question, even though they say this is f, this is always an issue with notation. That's a different f here than what's in the product rule. So I would say to you, even though they have f, and you say, well, is this the same f over here, which is the same here and over here? The answer is no. They're not the same f functions here. Okay, this is just a general way we describe functions. F for function. Just go straight to operator notation. And here's what I'm saying. Differentiate now this product, x squared for x minus 3. Where here is your f function, and then here's the g function. Okay, so there's a slight notation issue. You guys remember in class I said if you like, just call this maybe h. You can if you like. However, you could go straight to the f and g if you like as well there too. So we're going to find the derivative essentially just again of what you guys see here, which is a product. Okay, here's your product. We're multiplying these two functions. All right, now product rule. We have the derivative here of x squared. Sorry, let's go back. Let's think about that again. You're going to pull out this function here. You're going to pull out the x squared, and you're going to differentiate the second function. So pull out the first, differentiate the second, plus, now pull out the second function and differentiate the first function. Okay, so take a closer look. Here's the f. Here's the f. We're going to differentiate that here. Over here, we have the g. It's being differentiated, and here's the g. So this is really g prime, and this is f prime, and make sure we have that sum there. So we just have to now do the work. And so if we notice here the derivative of 4x minus 3, by now we should know that derivative is just 4. Derivative of a difference is difference of derivatives. Derivative of 4x, pull out your constant. That derivative is 4. Derivative of 3 is going to be 0. And similarly, the derivative of x squared we know is actually 2x. So altogether, here's what we get. X squared times 4 plus 4x minus 3 times 2x. Now, when you multiply here, because we're going to have to simplify this expression, here's what you end up with. 4x squared plus 8x cubed minus 6x. So that the derivative, if we simplify this function and write this actually in descending powers here, there's nothing really to simplify because we can't combine these terms. Here's our derivative. And if you call this f or you call this h, it doesn't really matter. You can say here's that f prime, although it's a different f. And again, if you like, you can call that again maybe h prime, because we just simply changed the name of the function so we could differentiate by this product rule as it's described with f and g. So here's a detailed solution of the first problem, and we're going to go through this procedure for every one. Remember, we're using here product rule because you have a product of two functions. Number 3. (5x plus 8) times 2x minus 7. So they gave us again that function in terms of f, and if it makes you feel better, right, go straight to the operator notation. You have 5x plus 8, 2x minus 7. And this will be your f function. It's a different f, different g. To be accurate, maybe you want to change this now to h, but it doesn't matter. Okay, so now think of the first function as a constant again. Pull it out, 5x plus 8. Differentiate that second function, which is 2x minus 7. Bring out the second function, 2x minus 7. Differentiate your first function, which is 5x plus 8. F g prime plus g f prime. And now we just have to do our derivatives. So the derivative of 2x minus 7 here is actually 2. And then the derivative of 5x plus 8 is 5. So you have 5x plus 8 times 2 plus 2x minus 7 times 5. You're now going to distribute. 10x plus 16 plus 10x minus 35. So here we can combine like terms, and we'll end up with 20x. Looks like it'll be 16 minus 35, which will be negative 19. So here's your derivative of the product. Number 5. They give us this f of x being x squared minus 4, x minus 8. F and g. This is a different f. So if you like, change that to h, right? Or go straight to your operator notation. You're going to use again the product rule. Okay, think of your first function as a constant, and then differentiate the second function. So let's double check here. First function is f, differentiate the second function, plus the second function times the derivative of the first. Here's what you get. Now here we go. Derivative of x minus 1 is 1, and again the derivative of x squared minus 4 will be 2x. Altogether, x squared minus 4 times 1 plus x minus 8 times 2x. So here you go. X squared minus 4 plus 2x squared minus 16x. So when you combine your like terms, you end up with 3x squared minus 16x minus 4. Here's your answer. And so you can call that h prime x or f prime x. It's a different f though. But you've taken the derivative using product rule. So here's your final answer. F of x is 3x squared plus 1 times 2x plus 7. And again, by product rule, here's your f, here's your g. It's a different f though, so if you'd like, change that to h, right? Or simply go straight to product rule. Here's that f and g function. Okay, and you're multiplying. So by the product rule, you get 3x squared plus 1 times the derivative of 2x plus 7 plus 2x plus 7 times the derivative of 3x squared plus 1. Differentiate your 2x. Differentiate your 3x squared plus 1. We end up with 6x. Just go back and remember this is your f, this is g prime, and this is g, and this is f prime. So altogether, here's what we have. 3x squared plus 1 times that 2x plus 2x plus 7 times the 6x. So when we distribute here, we end up with 6x cubed plus 2x plus 12x squared plus 42x. We can now combine our like terms. 6x cubed plus 12x squared plus 44x h prime x. Here you go. Here's number 7. Number 9. Here's your function. 5x cubed minus 3x x squared minus 2x plus 9. If you like, go straight to the operator notation. 5x cubed minus 3x times x squared minus 2x plus 9. So here's your first function. Here's your second. Again, it's a different f. So if it makes you feel better, let that be h. Now, using operator notation, bring out your first function as if it were a constant, 5x cubed minus 3x, and differentiate the second function, which will be x squared minus 2x plus 9. Now because this is extra long, I'm going to go down here and bring out the second part of this, which is to think of the second function as a constant, x squared minus 2x plus 9, and you differentiate the first function. Here you go. Let's differentiate 2x minus 2. And we get 15x squared minus 3. So here's our answer. 5x cubed minus 3x times 2x minus 2 plus x squared minus 2x plus 9 times 15x squared minus 3. So here we're going to have to multiply, and you're going to use FOIL here. Here you're going to have to multiply as well. We don't call it FOIL. You can call it FOIL-ish, I guess. But you're just going to multiply. So there's going to be some algebra here. So just be careful with the algebra. And so this is going to be, let's say that's equal here. And this information now is equal. Let's do FOIL. So we'll have 5 times 2, 10x to the 4th power, the first term. Outer term, negative 10x cubed. Your inner term is negative 6x squared. And your last term is plus 2. Now let's do the same for the next product here. So I'm going to take this 15x squared and multiply by everything here. So you're now going to get 15x to the 4th, looks like, minus 30x cubed. And then 9 times 15, it's 90 plus 45. It looks like it'll be 135x squared. So you could double check that work. Now we're going to take that negative 3 and multiply it to every term here. So we're going to have another row, I guess. And that'll be minus 3x squared plus 6x minus 27. So there's a couple of ways we could do this. I'm going to rewrite this down here. Minus 3x squared plus 6x minus 27. Let's do it over here. So we got minus 3x squared plus 6x minus 27. And now we're just going to add all the terms together here. So this will be equal. If you notice, we wrote it in kind of such a way where we can actually do our arithmetic in terms of these columns here. Okay, so I did align those here. This is not so aligned, so I could put the plus 2 out here. And there's just a single term here for the 6x. So we can write this answer in descending order here. All right, well, let's see. 10 plus 15 looks like we'll get, I'll put it here. Looks like we'll end up here with a 25x to the 4th minus 40x cubed. And then we have a negative 6 plus 135 minus 3. So it looks like negative 6 plus 135, that's going to give you 129 minus 3. That's going to be 126 x squared plus 6x minus, looks like 2 minus 27 is minus 25. Now here's the derivative of that function. Final answer. So you guys can double check the arithmetic here. So that's number 9. Number 11, you have the function being 7x to the 4th plus 5x cubed times x squared minus 5x plus 6. So going straight to operator notation, 7x to the 4th plus 5x cubed times x squared minus 5x plus 6. So here's our original function f. Here's our g, or I should say here's our first function, here's our g function, not necessarily original. Change that to h if you like. Okay, by power rule, you can pull out the first function as if it were a constant. So you have 7x to the fourth plus 5x cubed. Now you're going to differentiate the second function, which is x squared minus 5x plus 6, plus the second function, x squared minus 5x plus 6, thought of as a constant, times the derivative of the first function, 7x to the fourth plus 5x cubed. So if you need to go back and double check, here's your f. This thing together is g prime. And then here's your g. And then we have our f prime. And yes, we are adding. So you can double check there. Now let's go through our derivatives here. So by now, you should know this is 2x minus 5. And this here is 28x cubed plus 15x squared. So I can replace everything here with these terms. So you'll have 7x to the fourth plus 5x cubed times 2x minus 5 plus x squared minus 5x plus 6 times 28x cubed plus 15x squared. So here we multiply, and here we multiply. Now, this will be by FOIL. So we're going to have to be very careful here with our multiplication here. It's going to be a little bit of work. So let's just be careful. And I'll do the first one FOIL here. So first terms, 14x to the fifth. Outer terms, minus 35x to the fourth. Inner terms, plus 10x to the fourth. And last term, minus 25x cubed. Okay, I'm going to check something here for the prior question. Yeah, okay. Looks like we're fine. We made a mistake. No, I think we're good. Sorry. Well, anyway, you'll find it if there's an error here. I'm sure I'll hear about it. So here's your FOIL. Now, I'm just going to make sure, double check. 2x and 7x is 14x to the fifth, first terms. Outer terms, minus 35x to the fourth. Inner term, that'll be plus 10x to the fourth. Last term, minus 25x cubed. Now, here's what we're going to do with the second multiplication question. We're going to take this 28x cubed and multiply it to all three terms here. So let's be careful. Okay, anyway, 28x cubed times x squared, we're going to get now 28x to the fifth. So we'll put it here. Now 28 times negative 5 will give us, looks like it's negative 140. And that's x cubed times x, which is x to the fourth, so that's pretty good. And then 6 times 28 is 120 plus 24, 144. So that'll be 144 x to the third power here. Now that's this first term multiplied to everything here. Okay. Now, let's take the next term. 15x squared multiplied to everything here again. 15x squared times x squared is 15x to the fourth. Now 15x squared times that negative 5x, well, that's negative 75 right? X to the third power. So 15 times 5, let's double check. 50 plus 25, 75. And then it looks like we have a 15 times 6. Now 15 times 6 is going to give us, oh, what's this? 90. So that'd be plus 90x squared. Okay. Simply double check your arithmetic to see if you're okay. I want to say something here, though, that I'm going to combine these terms here. Negative 35x to the fourth plus 10x to the fourth, right? We have these powers here to the fourth. So this will give us negative 25x to the fourth here. So that now, when we do our arithmetic here, we start adding these terms. Hopefully we can see what we have here. Okay, so we're going to try to add all these terms together. So here we go. This will equal, and we'll give our final answer here. 28 plus 14, 38, is that 42 x to the fifth power, minus 25 minus 140 x to the fourth, that's minus 165 plus 15, that's minus 150 x to the fourth. And you got that minus 25 and a 145, or 144, and a minus 75. Well, minus 25, let's look at this. And minus 75, well, that'll give us minus 100. So 144 minus 100, that's going to be plus 44 x cubed, finally 90x squared. Now this is h prime x. Here we go. So double check the arithmetic, but this should be okay. And this is number 11 here. So this is how we go through this derivative. Number 13. F of x. 3x squared plus 5. 4x squared minus 5. Here's your f, here's your g. So if we go straight to operator notation, you're going to differentiate again the product. This is 3x squared plus 5 times 4x squared minus 5. Okay, so here's our product here. F times g. Like we've been doing, if it makes you feel better, and that's okay, you say this is h. So we're finding really h prime. Now by the product rule again, you're going to pull out that first function as if it were a constant. So you have 3x squared plus 5. And then we're going to differentiate the second function, which is 4x squared minus 5. Then we're going to add that to the 4x squared minus 5 times the derivative of the, looks like again, first function. So yeah, 3x squared plus 5. Okay, let's double check everything here. Here's f. That should be f prime. This is g prime, and this is g. And yes, we are adding here. So let's differentiate now. Okay. 4x squared minus 5, this gives you 8x. 3x squared plus 5 should give you 6x. So altogether, 3x squared plus 5 times that 8x plus 4x squared minus 5 times your 6x. So now let's distribute. You get 24x squared plus 40x. And then 6x times 4x squared, that's 24x squared, another 24x squared. I guess we could put it here, minus 30x. So double check your distributive property. 3x squared plus 5 times 8x, 24x squared plus 40x, 24x squared minus 30x. Okay, we can combine unlike terms to get our final answer. So this derivative will be equal to 48x squared plus 10x. And you're done. So this is number 13. Number 15. fx is 5x to the fourth minus 6x times 7x squared plus 1. So going straight to operator notation gives you 5x to the fourth minus 6x times 7x squared plus 1. So if it makes you feel better, call this h, because by now you know that this is really in product rule. My first function is f, the second function is g. Right, we have a product here. So what we're going to do is we're going to pull out the first function, think of that as a constant, and then you're going to differentiate the second function. 7x squared plus 1 plus 7x squared plus 1 times the derivative of 5x to the fourth minus 6x. So here's what you get. F g prime g f prime. So altogether, 5x to the fourth minus 6x. Well, we've got to differentiate first, so let's go do that. (14x) 20x cubed. Here we go. 5x to the fourth minus 6x times 14x plus 7x squared plus 1 times 20x cubed. So h prime x becomes, let's use some distributive property here. We end up getting 14 times 5 will be 70x to the fifth. 6 times 4 will be, this will be negative 84x squared. And 20 times x squared will be, it looks like 140x to the fifth. And then plus the 20x cubed. So we'll now combine like terms. And we don't have to put this h prime quite yet. Let's combine our like terms for the final answer. And let's notice that we have what? Fifth power. So this will give us 70 plus 140. That's 210 x to the fifth. And don't forget you have the x cubed power here, and it doesn't combine with any other term. 20x cubed minus 84x squared. So ladies and gentlemen, here you go. Here's number 15. Number 17. F of x is square root of x 7x minus 4. Now going straight to operator notation, d dx of square root of x 7x minus 4. Here's your f. Here's your g. And again, if you like, it's a different f, so call this h if you like. Different function. And something else is happening here. We're going to have to write this, if you take a look, the square root of x, if we're going to differentiate, you have to write this as x to the 1/2 power. So that derivative is x to the 1/2 power 7x minus 4, and we're going to multiply. So pull out the first function, you get x to the 1/2, differentiate the second function, 7x minus 4. Now pull out the second function, 7x minus 4, differentiate the first function. So, if you like, since we're running out of space here, put this down in the second line, 7x minus 4 times that derivative of square root of x, which is x to the 1/2. Now, derivative of 7x to the 4th is 7. All right, so double check. First of all, did we write this correctly? F, G prime, G, F prime. We look good. And then remember I said earlier, or the other day, or whatever you guys want to think of, you should probably know the derivative of x to the 1/2 because it's going to show up a lot, and that's 1/2 square root of x. So that's something that I think is good to know. And now we just have to do some arithmetic, do some algebra. X to the 1/2 times 7 plus 7x minus 4 times 1/2 square root of x. So when I distribute here, we'll get, and more than distribute, but here's what we mean. We're going to multiply and we're going to distribute here. Here's what we end up with. 7 times that square root of x plus 7x minus 4 over 2 times the square root of x. Now, this is the derivative here. Okay, let's actually write this as a final answer. And we can think of this as our answer for the derivative for now. In our future, like I said in class, we are going to use and apply these derivatives, and in that case, we're going to need to do some things like add these rationals. Okay, so we're going to have to remember how to add rationals as well, and that's going to come up in our future. Okay, so just stay tuned. We're going to get to the applications, and we're going to have to add these rationals, but for now, we're going to say this is okay because you're learning the product rule, and we'll get to doing more interesting things with these derivatives, which will include simplifying. So that's 17. Here's your final answer, and that brings us to 19. So your function here is, for 19, 4 times the square root of x minus 3x times x squared plus 5. F, G, say, is that the same F? No, change it to H if you like. So when I go to my operator notation, d dx of 4 squared of x minus 3x, x squared plus 5, bracket. This becomes 4 squared of x minus 3x times that derivative of x squared plus 5 plus, down here, x squared plus 5 plus times that derivative, 4 squared of x minus 3x. We're going to now have to differentiate here. All right, but before we do that, let's verify the product rule. FG, F, G prime, G, F prime. And yes, there's the plus. Okay, let's go and now differentiate here. So the derivative of x squared plus 5, well, that's 2x. Now let's do the derivative over here. This is 4 over 2 times the square root of x. That's for the first part of this. And don't forget, that'll be minus 3 because we have to take the derivative of minus 3x here. Okay, this derivative as well. So altogether here, let's see what we end up with. We have 4 square root of x minus 3x times that 2x plus x squared minus 5 times 2 over the square root of x minus 3. Because 4 divided by 2 will give you 2. And we're going to have to do some FOIL here. First distributive property, FOIL over here. So we're going to have to do some multiplication, if you guys recall. So let's multiply. This will be 8x square root of x minus 6x squared. And then if I distribute here, my first term will be 2x squared over the square root of x. That's the first term. And maybe we want to start writing everything down here just in case. Okay. So when I FOIL, this is where I'm looking at. X squared. I'm looking over here. Let's start to put it down here. Okay, so I'll put my equal sign. Plus 2x squared over that square root of x. Here's my first term. My outer terms, right? I'm going to have to multiply x squared with this minus 3. And that'll give you minus 3x squared. The inner terms now. Okay, you guys know negative 5 times that 2 square root of x. That's going to give me negative 10 over square root of x. Now the last term is going to be plus 15. So I'm going to have to do some simplification here for this answer. So we have 8x square root of x. This is minus 6x squared minus 3x squared. So we're going to combine those terms. That's going to give you minus 9x squared. And then we have 2 terms here as well. However, yeah, we have these 2 terms. Well, what we could do here, we can combine these. Yeah, or you know what we can do simply? How about this? We're going to rewrite this term here. I mean, we could do a little bit more algebra, but we're going to keep it simple for our answer since we're first learning this. And if you guys recall, this portion here that I'm going to look at in more detail, let's change that color here. This is what we're going to think of here in terms of the work. X squared over x to the 1/2 becomes x to the 2 minus 1/2, or simply x to the 4/2 minus 1/2, which will give me x to the 3/2. Written as a radical, we get cube root of x squared, which is going to be, yeah, cube root of x squared, 3/2. Sorry, let's be careful. It's the opposite. It's a square root of x cubed, which gives you x squared of x. So this is what we get when we simplify this portion here. And, okay, let's write this all down now. You can replace this portion here, if you like, with plus 2x square root of x minus 10 over square root of x plus 15. So when we combine our like terms now, we're going to notice here, we'll change the color, 8x squared of x plus 2x squared of x. Let's write this as 10x squared of x minus 9x squared minus 10 square root of x plus 15. And we could leave it like that. And I can do some more simplification if you like. I'll say here's h prime x, 10x square root of x minus 9x squared minus 10 over square root of x plus 15. We can write our answer this way after doing some simplification. And then some people are going to say, wait a minute, we should always rationalize our denominators, right? So the work over here, when we rationalize the denominators, let's look at this work. You can see in back of the book, 10 over the square root of x, now times that square root of x over square root of x. We multiply fractions horizontally across is 2 square root of x, and square root of x times square root of x over here is simply going to be just our what? Our x. So we rationalize the denominator. So all together now, with our simplification, the derivative of this function is 10x square root of x minus 9x squared minus 10 square root of x over x plus 15. So we had some simplification here, and it's not too bad, but this is how we go about using product rule, at least from the start here. Okay. That'll be it for this.